So today let us start a new chapter of the 10th standard, that is refraction of light at curved surfaces. So let us see an activity before going into this lesson. So for this activity, just consider a beaker with water. Consider a beaker with water, and I have considered a paper. I have drawn an arrow mark with black pen. So let us consider a water with beaker and black pen and an arrow and a paper with having some arrow mark. So if you observe the arrow mark, the direction of the arrow mark is towards the left hand side. So if you are observing the direction of the arrow through this beaker, what you will observe is the direction of the arrow is reversed. The direction of the arrow is reversed. If you observe the direction of the arrow, it is towards in this direction. If you observe the direction of the arrow through the glass beaker containing water, the direction of the arrow will be towards this side. So how this is occurred? How this occurred? So here if you observe, this is the air medium, and here the surface is a curved surface. Here the glass beaker is having some curved surface. So this phenomenon can be explained with the help of refraction of light at curved surfaces. Here the surface is not a plane surface. Here the surface is a curved one. So in order to know how this was happened, we need to know how the refraction of light occurs at curved surfaces. So in this lesson, we are not going to deal with a complicated curved surfaces. We are going to deal only spherical curves. We are dealing only with spherical curves. So what is meant by a spherical curve? What is meant by a spherical curve? So let us consider a tennis ball or a rubber ball. Just consider the ball, and if you cut the ball like this, the remaining portion will be, let us cut the ball with some portion. Let us consider a small portion of the ball, and here you will have a curved surface, and the curved surface is a part of the ball which is in the shape of sphere. That curved surface is a part of a ball which is in the shape of a sphere. So such curves are called as spherical curves. What is meant by spherical curves? The curves which are the part of the spheres is called spherical curves. The curve which is the part of a sphere, the curves which are the parts of a sphere is called as spherical curves. So in this lesson we will only deal with spherical curves. We will deal with spherical curves. So in the previous lesson, while studying the refraction of light, in order to measure the angle of incidence or angle of refraction, you need to know about the normal line. You need to know about the normal line. For example, if it is a plane surface, the normal line is perpendicular to the surface. What is normal line? The line which is perpendicular to the surface is called as normal line. The line drawn perpendicular to the surface is called as normal line. Then how the normal line will be for a spherical surface? If I have considered a spherical surface, how can we draw a normal line here? So since it is a spherical surface, this spherical surface is a part of a sphere. The spherical surface is a part of a sphere, and this particular sphere will have some center. The sphere or the circle, here it is a three-dimensional object. The sphere will have center, and that center is called as center of curvature, which is denoted with C. C is center of curvature. This is the center point of the curve. This is the center point of the curve, and this curve is a part of the sphere. This curve is a part of the sphere. In this lesson, we will only deal with spherical curves. So this C is called as center of curvature. Center of curvature. So if C is the center of curvature, so if you want to draw the normal at this point, At this point, if you want to draw the normal line, the line joining this point and the center of curvature is called, will denotes a normal line. So if you want to draw a normal line for a plane surface, you need to draw a perpendicular line. So if you want to draw a normal at this point, you need to draw perpendicular line at this point. So in the case of spherical curves, if you want to draw a normal line, you need to connect the point on the curve and the center of curvature. Then that line denotes the normal line. For example, if I want the normal line at this point, you have to connect the point center of curvature and this point. So the line joining the point and the center of curvature will denote the normal line at this point. So this indicates the normal line. This indicates normal line. And center C is called as center of this curvature. This is the center of this curvature. For this curved part, for this curved surface, C is the center. And the distance between the center to any point on the curve is called as radius of curvature. Here, the distance between the center of curvature to any point on the curved surface is called as radius of curvature. So this is the terminology we need to know about curved surfaces. Radius of curvature. This curve is a part of the sphere, and hence the center of that sphere will be the center of the curvature, and the radius of that sphere will be the radius of curvature. And the line joining the center of curvature and the point on the curved surface will denote the normal at that point. So let us see how the light will be refracted at curved surfaces. I have considered a spherical curve. This is spherical curve is will be similarly in this shape, and this spherical curve will have two surfaces. One is bulging surface and another one is having inward bend. The spherical surface will have two surfaces. One is bulging one and another surface will have some inward bend. And the bulging surface is called as convex surface. This bulging surface is called as convex surface. And this inward curved surface is called as concave surface. Concave surface. Here you have considered a spherical curve, and the spherical curve consists of two surfaces. The bulging surface is called as convex surface, and the inward bent surface is called as concave surface. So let us consider the case when the light is incident on the convex surface. Let us consider the case when the light is incident on the convex surface. So this is the situation when light incident on the convex surface. So I have considered a curved surface, and this is the center of curvature C, and the midpoint of the curved surface. The midpoint of the curved surface is denoted with P, and it can be called as pole. You can call this as pole. The line joining the pole and the center of curvature is called as principal axis. The line joining the pole and center of curvature is called as principal axis. So let us consider a light train. So here this curved surface is separated into two mediums, whereas the first one is rarer medium and the right hand section is denser medium. So this curved surface is separating two mediums. The right hand section is denser one and the left hand section is rarer medium. So let us consider a light ray. That is incident on a convex surface. To find out the angle of incidences or to know how the light bends, we need to draw a normal at this point of incidence. You need to draw a normal at this point of instance. So how can you draw the normal at this point of instance? The line joining the center of curvature and this point will denotes normal line. So this is the normal line. This is the normal line. The line connecting the point and the center of curvature denotes the normal line. So here, this is the actual path of the light ray. This is the actual path of the light ray. If you observe here, the light ray enters from rarer to denser medium. The light ray traveling from rarer to denser medium. So when light travels from rarer to denser medium, how it will bend? It will bend towards the normal. It will bend towards the normal. So when light travels from rarer to denser medium, it will bend towards the normal, and hence the light will take a path like this. A light will take a path like this. So let us see another case. So this is the case where we have considered right section as denser and left section as rarer. So let us reverse the mediums. So again I have considered a curved surface, and this is the center of curvature C. The midpoint of the curved surface is called as pole. The line joining the center of curvature and the pole is called as principal axis. So in this case, I was reversing the situations. So the right hand section as rarer medium, and the left hand section as denser medium. So here I have reversed the situations, and in both the cases the light is incident on a convex surface. In both the cases the light is incident on a convex surface. To know the bending direction of the light ray, we need to draw the normal line at this point of instance. So the line joining the center of curvature and the point is called as a normal line. This is the normal line. So the light, this is the actual path of the light ray when there is no change in the medium. So here the light ray travels from denser to rarer medium. The light ray travels from denser to rarer medium. What happens when light ray travels from denser to rarer medium? It will bend away from the normal. This is the normal line, and this is the actual path of the light ray. So it will bend away from the normal line. It will bend away from the normal line. So these are the two situations when the light incident on the convex surface. These are the two situations when the light is incident on a convex surface. So let us see the case when the light is incident on a concave surface. So I have considered a spherical curved surface. So this inward curved surface is called as concave surface. This is the center of curvature C, the midpoint of the curve, pole, the line joining the center of curvature, and the pole is principal axis. So now consider this section, the left section as rarer medium and right hand section as denser medium. So now consider a light ray parallel to the principal axis. So you need to draw a normal line at the point of instance in order to observe the refraction of light. So I have drawn a point of instance here. I have drawn a normal line, a line connecting the center of curvature and the point of instance, and that line denotes the normal line for a curved surface. So this is the actual path of the light ray. So when light ray travels from rarer to denser medium, it will bend towards the normal. It will bend towards the normal. So this is the case when the light is incident on a concave surface. Just reverse the mediums, separated by the concave surface, and again observe the refraction of light. So this is the center of curvature of the curve, and the midpoint of the curve is pole. The line joining the center of curvature and the principal axis. And now in this case we need to consider the denser medium and right hand section as rarer medium. And let us see how the light will be refracted. So I have considered a light ray parallel to the principal axis. So in order to know the refraction of light ray, we need to draw a normal line connecting the point of incidence and center of curvature. So this is the normal line, and light rays traveling from denser to rarer medium. When light ray travels from denser to rarer medium, it will bend away from the normal. It will bend away from the normal. This is the actual path of the light ray. This is the actual path of the light ray, and in upper portion there is a normal line, so it bends away from the normal in the downward direction. So these are the refractions of light rays that was occurred on the spherical curves. These are the situations that shows the refraction of light rays at spherical curves. That means at curved surfaces. So let us know about how the direction of the arrow is reversed when it is viewed through a water, through a beaker containing water. A beaker containing some water, and I have placed an arrow here. By observing this arrow through the beaker, from the other side of the beaker, we will observe the direction of the arrow is reversed. If the arrow is pointing in the upward direction, if you are observing from this side through the glass beaker, you will observe the position of the arrow in the downward direction. So let us see how that was occurred. So the light is coming from the head of the arrow. The light is coming from the head of the arrow, reaches to the curved surface, and it will get refracted here, and the light is coming from the tail section incident on the curved surface and gets refracted like this. So again at the second surface, again the refraction will be observed. And you will find the direction of the arrow as in the reverse direction. So here the light rays coming from the head of the arrow reaches to the bottom of the other side, and the light rays coming from the tail of the arrow reaches to the upper section of the other side. So in this way, the light rays, due to the refraction of light rays, we will observe an reverse image of the object. Here the object is an arrow, and sometimes we will observe some magnified images. Here the arrow, the size of the image will be greater than the size of the object, greater than the size of the arrow, and hence sometimes we will observe the magnified images depending on the distance between the arrow and the glass beaker. Sometimes we will observe the magnified images. So because of the refraction of light at curved surfaces, we are observing the direction of the arrow as reversed. So because of the refraction only, in some shops you will observe the lemon kept inside the glass beaker appears larger than its actual size. It is also due to the refraction of light at curved surfaces. So let us know about the lenses. Let us know about lenses. So I think you are very well known with the magnifying lens. This is a lens. So we are well known, and we have played so many times with this lens. So this is a magnifying lens. So let us know how many types of lenses are there, and what is occurring inside the lens. How the light will behave when it is passes through the lens. Let us know about that. So what do you mean by lens? A lens is formed by a transparent material bounded by two surfaces, in which at least one surface is curved surface. For example, if I have considered a plate, a glass plate I have considered a glass plate. So this the glass plate will have a plane surfaces. So you cannot call it as lens. A lens must have at least one curved surface. A lens is bounded by two surfaces, and among that at least one surface must be curved surface. Then only that object is called as lens. So, what are the different types of lenses? So the lens which is having bulging curves, is called as a convex lens. So this lens, the two surfaces of the convex lens are bulging outwards. So hence it is a convex lens. We can call it as convex lens or biconvex lens. So the biconvex lens, thickness of the biconvex lens at the middle is greater when compared to its thickness at the edges of the lenses. When compared to the edges of the lenses, the thickness of the lens is greater at the middle of the lens. And another type of lens is biconcave lens. The two surfaces of the lens are concave surfaces. So this is the concave. The two surfaces are concave. This lens is called as biconcave lens. So the biconcave lens will have less thickness at the center when compared to its edges. So you can denote this convex lens as a double-headed arrow. So we can denote this convex lens as like this, and we can denote this concave lens as with a symbol like this. You can denote the lenses with some convex lens as double-headed arrow, and biconcave lens can be denoted as like this. So these are the two main types of lenses, and see there are some other types of lenses also there. So one is plano-convex lens. Here one surface is plane and another surface is convex surface, and hence this lens is called as plano-convex lens. And one surface is plane and another surface is a concave surface. This lens is called as plano-concave lens. This lens is plano-concave lens. And one surface is a concave surface and another surface is a convex surface. This is the convex surface, and from this side the surface is the concave surface. And this type of lens is called concavo-convex lens. So these are the main different types of lenses, and these are the different shapes of lenses. Just remember that convex lens can be denoted like this, and concave lens can be represented like the symbol I have represented here. So let us see some terminology of the lenses. So I have considered a convex lens. And it is bounded by two surfaces, and the two surfaces are bulging surfaces. The first surface is a spherical surface. Here we are dealing in this lesson. We are dealing with spherical curves. So here the first surface is a spherical curved surface, and this surface is a part of a sphere. The spherical surface is a part of a sphere, and the center of the sphere is called as center of curvature, and I was denoting it as C1. So the center of curvature of the first surface of the convex lens is located on the right hand section of the convex lens, and the center of curvature of the second surface lies in the left hand section of the convex lens. The curved surfaces of the lenses are the parts of the spheres, and hence the sphere has some center. That center is called as center of curvature. For the first surface of the convex lens, it is situated in the right hand section, and for the second surface, the center of curvature is located in the left hand section. So hence it is denoted as C1 and hence here it is denoted as C2. So as we previously known that the distance between the center of curvature C1 and to any point on the surface is called as radius of curvature. So hence it is denoted as R1 and it has R2. The midpoint of the lens is called as pole. The midpoint of the lens is called as pole. The midpoint of the lens is called as pole, and the line joining the pole and the center of curvatures are called as principal axis. So if I consider a convex lens, the first surface center of curvature will be here, and hence it is denoted as C1. The center of curvature of the second surface will be lies in the left hand section of the lens. It is denoted with C2. Then it will be a midpoint of the lens denoted with P, and the line joins the center of curvature and the pole is called as principal axis. So similar to this way, there will be center of curvatures for concave lens also. So here, if you observe the first surface, the sphere will be like this. Hence, the center of curvature of the first surface will be in the left hand portion, whereas the center of curvature of the second surface will be in the right hand portion. And this is the midpoint of the lens P. For convex lens, C1 is situated in the right hand section of the lens, whereas for concave lens, the C1 will be situated in the left hand section of the lens, and the midpoint of the lens is called as pole. So let us know about focus point. So I have considered a convex lens, and the line joining the center of curvature and the pole is called as principal axis. So let us consider light rays parallel to the principal axis. Consider the light rays parallel to the principal axis. So some light rays which are parallel to the principal axis are incident on the lens. So these light rays will be refracted by the convex lens and focuses to a point. This point is called as focus point. Let us see what happens when it is in the case of a concave lens. So I have considered a concave lens. So the line joining the center of curvature and the pole is principal axis. So let us see what happens when it is in for the case of concave lens. So I have considered light rays parallel to the principal axis. So when light rays are incident on the principal axis, these light rays will be diverged by the concave lens, and this diverged light rays will seems to be coming from a point called as focus point in the case of concave lens. Here, in the case of convex lens, the parallel light rays will be converged to a point. Converged means they are directed towards a particular point. And that point is called as focus point for the case of convex lens. But here, the light rays are diverged, and diverged light rays seems to be coming from a point. Seems to be emitting from the point. Here, the light rays seems to be emanate from a point. And this point is called as focus point. And one more important point is the convex lens can converge the light rays, whereas the concave lens will diverge the light rays. And hence convex lens is also called as converging lens, whereas concave lens is a diverging lens. So now let us see how can we define this focus point F. What is focus point? when light rays parallel to the principal axis are incident on the lens, those will be converged to a point or seems to be eminent from a point called as focus point. The relation between the center of curvature and focus point is C is equal to 2f. So the focus from that relation, the focus point is situated exactly at the center of the pole and the center of curvature. So this is very important point. The focus point for a lenses which are formed by spherical curved surfaces, the focus point is situated at the midpoint of the pole and center of curvature. So we have seen the terms related to the lenses. What are the terms? That is center of curvature, and another one is radius of curvature, pole, which can be also called as optic center, and we learned about focus point. So now let us see some behavior of light rays when they are incident on the lenses. Let us see the behavior of light rays. Behavior of some light rays. So I have considered a convex lens. And can be represented as a double-headed arrow. So for this convex lens, C1 will be situated in the right hand section, and C2 will be located in the left hand section. So the midpoint of the lens is called as pole. So this is the line joining the pole and the center of curvatures. So the light ray, let us consider a light ray along the principal axis. So the light ray which is passing along the principal axis will follow an undeviated path. So this is the first case, that the light ray which is along the principal axis is parallel, will follow an undeviated path. So of course if you consider a concave lens, the light ray along the principal axis will follow an undeviated path. So this is the first case. When light ray is traveling along the principal axis, it follows an undeviated path. So let us consider another case, second case. So I have considered a convex lens, center of curvature of the first surface C1, center of curvature of the second surface C2, midpoint of the lens P. So now I have considered a light ray passing through the pole. So now I have considered light ray, it is not along the principal axis, but passing through the pole. So when the light ray is passing through the pole, then also light ray follows an undeviated path. Undeviated means there will be no change in the direction of the light ray. Of course, if you have considered the concave lens, when the light ray is along the pole, it follows an undeviated path. So when the light ray is passing along the principal axis, or when the light is passing through the pole, the light ray follows an undeviated path. So let us consider the light ray, the third case. This is the third case. So center of curvature C1, center of curvature C2, pole P. So let us consider the light ray parallel to the principal axis. Then how the direction of the light ray will be changing? How the light ray will be deviated? So when the light ray is parallel to the principal axis, the light ray will pass through the focus point. The light ray will be directed towards the focus point. When the light ray is parallel to the principal axis, the light ray will passes through the focus point. The refracted light ray passes through the focus point. So let us see the case. What happens is the midpoint of the lens called as pole, and center of curvature C1, and this is the focus point F1. On the other side of the lens C2, center of the focus point F2. So if the light ray is parallel to the principal axis, this light ray will move away from the principal axis and appears to be coming from the focus point F1. In the case of concave lens, the light ray is parallel to the principal axis. The refracted light ray seems to be coming from the point focus F1. So in the case of convex lens, if the light ray is parallel to the principal axis, the refracted light ray is towards the principal axis. The refracted light ray in this case is away from the principal axis and seems to be coming from this point F1. Here, the refracted light ray is towards the principal axis and passing through the focus point F. So let us see the fourth case. When the light ray is passing along the focus point. So if the light ray is passing along the focus point, the refracted ray will be parallel to the principal axis. When the light ray is passing through the focus point, the refracted ray will be parallel to the principal axis. Let us see the case of concave lens. If the light ray is passing through the focus point F2, the light ray is passing through the point focus F2, then the refracted light ray will be parallel to the principal axis. So these are the behaviors of light rays when they are passing through the lenses. So in the next session, we will learn how these lenses will form the images of the objects, and what are the types of images and what are the natures of the images that these lenses can form. We will discuss in the next session. Thank you.